A truth table is a table that specifies what you want the output of your logic circuit to be given a certain input. But how do you find the Boolean expression based on the truth table? A Karnaugh map is a special kind of truth table that can help us do exactly that. In this truth table we have 3 inputs, so we need a K-map with 2 to the power 3 cells, where every cell represents an input combination from the truth table. The input values are written in a specific order on the K-map where 2 adjacent cells must only differ by 1 input bit. So in the first cell all the inputs are 0, in the next cell B changes to 1, then A changes to 1 and so on. So as you can see, only one of the inputs change when moving to an adjacent cell. What I'm about to tell you will be important information later, and it'll help you avoid a common mistake that people make. K-maps wrap around, so in this K-map these 2 cells are adjacent and so are these 2, which is why a K-map is actually best represented as a 3D shape. Imagine connecting the left and right sides so that we end up with a cylinder. In a larger K-map, the top and bottom also connect, so in reality, if we want both the left and right sides to touch and the top and bottom to touch at the same time, we are going to end up with a torus, which is the mathematical name for a donut shape. Just imagine the cylinder wrapping around to form a donut. To find the Boolean expression using this K-map, we have to circle all the ones. We could circle all of them individually and get a correct expression, but it would be unnecessarily long. To get the shortest expression possible, we have to circle them in groups while following some rules. The number of cells in a group has to be a power of 2, so 1, 2, 4, 8, etc. And we want as few groups as possible, and we also want the groups to be as big as possible. We can circle these 2, and remember the K-map wraps around, so we can circle these 2. Now we just need this last one, but we want the groups to be as big as possible and they're allowed to overlap, so we'll circle these 2. Another option would be circling these 2, but in this case it doesn't really matter which of the options you choose. Now, to figure out the expression, we need to figure out which of the inputs stay the same in all of the cells in each group. In the first group, B is 1 and C is 0 in both of the cells, so we write B times C negated. In the next group, B is 0 and C is 1 in both cells, so we write plus B negated times C. And in the last group, A and B are 1 in both cells, so we write plus A times B. And this is our final expression, and if we draw the circuit, which I explained how to do in my last video, it ends up looking like this. In our next example, we have 4 inputs in the truth table, so our K-map needs 2 to the power 4 cells. The X's in the output are don't cares. If there are certain input combinations where we don't care what the output is, instead of setting the output to 0 or 1, we can set it to don't care, and that can help us end up with the simplest expressions possible, but more about those later. In the K-map we see right off the bat that the largest group the one in the first cell will fit in is this group, which gives us B negated times D negated. In this cell, the largest group that will fit this cell is this group, which gives us A times B negated. The thing with the X's, or don't cares as we call them, is that you're allowed to circle them to help fit all the ones into groups that are as big as possible, but you don't have to fit them into any group. You have to circle all the ones and you're not allowed to circle any zeros, but when it comes to the X's, we don't care about them, they're only here to help us. Then there's this one up here. The largest group it can fit in is this group, which gives us A times D negated. The last cell with the one that hasn't been circled yet is this one. And remember, the size of a group has to be a power of 2, so this group would be invalid. So the largest group that we can find for this last one is this group. This group only has a size of 2, and because of that 3 of the inputs stay the same. So this gives us A negated times C times D. As you can see, a smaller group adds more length to the length of the expression, which is why we pick the biggest groups possible.